Hi, so this proof is going to be let V and W be vector spaces and let the mapping of V to W be a linear transformation, then the range of T is a subspace of W. So suppose that V and W are vector spaces and T is a transformation such that T maps V to W. So in order to be a subspace, there are three properties that must hold. So to be a subspace, number one, T must not be empty. Number two, the range of T is closed under addition. And this basically means that if X and Y are elements of the range of T, then the transformation of X plus Y is an element of the range of T. For property 3, the range of T, it must be closed under scalar multiplication. And this basically means that if the transformation of X is an element of the range of T, then alpha times the transformation of X is an element of the range of T for all alpha is an element of F. And also the alpha should be inside, so it should be the transformation of alpha X is an element of the range of T. So either way. But for requirement 1 of this proof, zero vector is an element of V because it's a vector space. It's one of the properties. And so the transformation of the zero vector is going to equal the zero vector of W. They're both vector spaces. They both have zeros. So that means that the zero vector is in the range of T. And this means that the range of T contains the zero vector and is not empty. So property 1 holds. For requirement 2, suppose that X and Y are elements of V and that the transformation of X and the transformation of Y are elements of the range of T. Since X and Y are elements of V, this means that X plus Y is an element of V. So the transformation of X plus the transformation of Y equals the transformation of x plus y and is in the range of T. So basically, you have the elements x and y in vector space V. Because it's a vector space, x plus y is also in V, and the transformation of x and the transformation of y are in the range of T. Since you can add two vectors and get a vector back in the vector space, this will be the same with the transformation. For requirement 3, suppose alpha is an element of F and transformation of x is a vector in range of T, since x is an element of V and V is a vector space. Alpha x is an element of V. So alpha times transformation of x is equal to the transformation of alpha x and is an element of the range of T. So since these requirements to be a subspace hold, so since these properties of a subspace hold, the range of T is a subspace of W. And that is all.